Hi, everybody. My name is Moshe Zadka. My website is cobadism.com, where you can find every way of reaching out to me, known to humankind. And today I'm going to talk to you about iteration in Python. And the first part is explaining the difference between two very closely related things that have an important nuance between them. And that's the concept of an iterable. An iterable is something that has a method under iter, and it returns an iterator. What's an iterator? An iterator is an iterable that has a method under next that returns an item or raises top iteration. It is an instance of iterable, so it also has a method under iter. And one thing that you cannot specify by the type system, but it is true, the iter method on an iterator returns self. And so the dunder iter method is idempotent. You can call it as many times, and it will only, kind of change the value once, and that's going to be important later. As usual, we don't call dunder methods directly on objects, and often with Python, just like say with int, right? You don't call dunder int directly. You call the int function, and it will either call the dunder method on a Python level object, or it will call the um, right method on a C-level object. So that's how you actually use those. You run iter or next. Right, those are built-in functions. You don't actually have to define them. And so let's define a simple iterable. So remember, iterable only has one method, or only has to have one method that has dunder iter. And in this case, we'll just hand off it to something else as iterator. So we'll build a list of two things, and then we'll ask for the iterator of that. The iterative list, as you can imagine, will return the two things. So let's see how it works. We'll call next on the first one, then next on the next one, and we'll get 1 and 10, which is the two ints that we had. That's great. Now let's write an iterator. So as you can see with an iterator, you actually have to have a state. You cannot have a frozen class. So to simplify things, I'm just going to hard code. This iterator will always return just 1 and 10. And the way I'm implementing next is I return the first thing in the list, and I also remove it from the list. And if there are no items in the list, I raise a stop iteration. So that follows the iterator protocol almost, because I didn't implement dunder iter. But as always, Python is going to give us some leeway. So in order to fit in on slide, I'm not going to implement dunder iter here. And as you can see, we call next, it does the same thing. This time we didn't have to call the iter because it's already the iterator. And just to show that it does the exception correctly, if you call next again, then it will raise stop iteration. And that's true whether you use the iter deck via just iterate on two items, or if you use any of the iterators that we've returned so far. So in order to show how for does it, I'm gonna use the same iterator that we wrote before, but this time I'm actually gonna implement dunder iter because I have to, and I'm also gonna put a lot of prints in dunder next. So as you can see, this time I'm getting the ret value and not returning it directly. If I get an exception, I print that this is the end of the iteration, and I raise the stop iteration exception, and then I call dunder next, and then I make a print that I'm returning the value, and then I return the value. All these prints will make it really easy to see what's going on. And as you can see in the for loop itself, I'm also gonna put a lot of prints, right? So I put a for before and a print inside the for, and a print after the for. And as you can see, before it, right, I have a print. You'll notice that like dunder next is not gonna get called, right, until I actually call the for. So then the first time I go there, I return 1, and then the value is going to be 1. So I get 1. Same thing with 10. And then the next is going to be end of iteration, which means I'm not going to go for another iteration, right? I don't have a value for that. So we end the loop. And this is how loops are connected to iterators or iterables. In fact, this is why I needed to have the dunder iter methods, because for always assume it's an iterable, so it will always call the equivalent of iter of internally. The other way of using iterators or iterables is to call list or any other sequence constructor that will just consume all the items in the iterator and will put them in the sequence. Easiest is list. And as you can see, we have all the prints before we get the result, and then the result is the item. Those are the two main ways that you'll naturally be using iterators or iterables in Python. Now, what's the connection to generators? Often people use generators and iterators in closely related ways. An iterator is a protocol. It specifies what has to happen when you call dunder iter, what happens when you call dunder next, and so on. It's annoying to implement. If you remember, like when I tried to implement it myself, it was unpleasant, right? I had to like write complicated states. I had to recover from exceptions, and I even had to cheat a bit by like putting stuff in a list so that it will be easier for me. And if I had to do it in production, that would potentially take up a lot of useless memory. It's not pleasant to write iterators. Generators give us a mechanism to build iterators that is much more pleasant. So I promise it will be much more pleasant. Here's how much more pleasant it will be. This is the same iterator that I wrote before, right? Remember before I had to implement dunder init, dunder iter, and the dunder next was this kind of complicated try and accept. This is the same thing, right? It has the same equivalent prints, right? Begin, middle, end. And that's it, yield and 5 lines instead of like the 20 odd complicated lines I had to write before. And if we use it in like a for loop that's very similar to what we've written before, then again, we have the before, begin, got 1 middle, got 10 end. After the end, it raises stop iteration error, and the loop ends. So generators are a much faster way to implement the iterator protocol. And one other thing that I want to cover in using generators is that you can use yield from, and that's often a way to use another generator in a generator or another any iterable. It will work, right? So if I want to, I have like the old list of 1 and 10, and I like that, so I got the 1 and 10, and so I yield from to iter, and then I yield the 100. And now if I use the list, right? Remember that's the other way of using iterators. Then I get 1, 10, and 100, and the prints all come before I get the list. I already explained that to consume an iterator, you can use a sequence constructor. What if you want to consume the sequence and you're not interested in the actual value, only interested in the side effect, in this case, the print? Then there is an interesting sequence type in collections called DQ, double-ended queue. And one of the useful things about it is that it has a max length. And if you give it a maximum of 0, then it will consume the iterator. It will add each item as it goes, but it will add it to a 0-sized DQ. So it will add it and throw it away immediately. And so you'll end up with an empty DQ and the side effect. So this is a nice way to consume a generator just for the side effect. So a lot of functions in Python accept any iterable and return an iterator. Now, if you remember, any iterator is an iterable, which means all these functions can be composed together, right? Because the return value of one function can be fed into it or any of the other functions, and that can be fed into any of the other functions, and that can be fed into any of the other function. So let's give some examples of functions that you can use in your own life that will probably be useful. The first is like a pretty cool built-in called enumerate. Um, if you go enumerate an iterable, then it will return an iterator with tuples of the original value and the index. That's very useful if you need the running index to say print every 10th item, makes it much easier. Map takes a function and an iterable, and it will return to an iterator that does the function one step at a time. So I add 1 to an iterable of 1020, and I get 1121. Filter, right? So map modifies the element. Filter doesn't modify the element. You get the original element, but not all the elements. So in this case, I asked for all the things that 5 is greater or equal to. So in other words, things that are smaller than 5. So on a list of 1, 10, and 3, I'll only get 1 and 3. Zip takes any number of intervals and just returns to you a tuple of the elements from all the iterables as an iterator. And if none of these work and you need anything that consumes an iterable and returns an iterator, you can make a generator expression, right? So double plus 1, it means 2 times a plus 1. And then I just give it 1 and 10, and I get 3 and 21. If you added if, it will also function as an ad hoc filter. Now, I showed you how you can have some built-in functions. I can show you how you can define your own functions, but there's also a whole module built into the standard library, which is just dedicated to give you even more functionality like that, and that's itertools. I'm not going to go over all the functions in itertools because it's a lot, but I'm going to give you a little taste so you can see what kind of thing to expect. But basically, it gives you a lot of useful advanced iterator algebra things. First thing, chain, right? That's very useful because you can have 3 items and then say another 2 items, and you'll have one iterator that goes to the first one and then the second one, and you can have third and fourth, and you can have any number of iterators there. So it's a very useful kind of iterator addition operator. iSlice is basically the equivalent of slicing a list, but for an iterator, right? The nice thing is it doesn't build the list in advance, right? Like it's an iterator, so it will only consume as many elements as you will need it. And it's very useful because you can also use it on infinite iterators. Itertools count is an infinite iterator that just counts. And I can slice the first 5 elements so I can have a finite iterator that counts. And then I give it to list to kind of consume it so you can see what's in it. Let's say none of these things help you out. There's a third-party library from PyPI called More Itertools. You can imagine what's there. You can imagine that I'm still not gonna tell you all the functions in it, but I'll give you a little taste. So when itertools is not enough, for example, you can have chunked. Very useful if you have an iterator and you want to work on things in batches. Maybe like you want to edit into a database in batches or use a REST API or something like that. You can use distribute, which will kind of separate it into a few streams. That's useful if, say, you want to distribute it among several threads or maybe even several CPUs or anything like that. You can use pickable, which will let you pick into the future so that you can say, as soon as you see 3, don't give me any of the items. So stop at the item before 3. So as you can see, I get 0, 1, and I don't want 2 because 2 is the one preceding 3. So this is nice, right? I can pick, and I didn't consume the 2. So if I give the iterator to something else, it will consume it. Windowed, my favorite thing to do with windowed is just get like the list of differences, but you can also do it for like rolling averages or something like that. So what do I want to leave you here with? Iterators and generators. Iterators are useful interface. Generators are a useful way to implement that interface. If you use them together, you can code Python in a much more powerful way because you get an algebra of just in time. You basically have a whole lot of functions that accept and return iterators, and that gives you composable just in time tools. There's a huge ecosystem of them. So before you need something, or before you use something, do your research, use whatever you find. And if you find you have something new to contribute, some other primitive of iterate algebra, contribute it back to the ecosystem and you make everyone better off. Thank you very much. I hope that was useful and have a great rest of your conference.